Hello everyone, and welcome back to Edulexis. Today is day 46 of our Python journey, and we are going to master one of the cleanest, safest, and most professional tools in Python, the with statement, also known as context managers. If you have ever written code to read files, connect to databases, or handle network streams, this tool is going to save you from hidden bugs and unexpected memory leaks. Don't worry if it sounds advanced. By the end of this short 15-minute lesson, you will be using it effortlessly. Let's jump straight in and understand the exact problem this statement solves. Before we look at the solution, let's understand the core problem. In software development, your operating system has limited resources, like file handles or network ports. When your Python script opens a file, it borrows a handle from the operating system. If you keep opening files without closing them, your computer will eventually run out of handles, causing your program, or even your entire computer, to slow down and crash. Therefore, the absolute golden rule in programming is every time you open a resource, you must explicitly close it when done. Let's see how beginners traditionally handle this. On my screen, you can see the standard way. We create a variable f, call the open function to create or open a file called data.text in write mode, write some text into it using f.write, and finally, we call f.close to release the file back to the system. This looks completely fine. Simple and logical on the surface, right? But this approach has a massive, hidden flaw that every professional Python developer knows about. What happens if an error occurs before we reach the close line? Let's simulate a crash by inserting a zero division error right before we write to the file. When Python runs this, it hits the error, stops execution instantly, and crashes. Because it crashed early, it never reaches line 5, meaning f.close is never executed. The file stays locked in your computer's memory. This is called a resource leak, and it happens all the time in real-world application workflows. To fix this issue without the with statement, older programming languages use a try finally block. Here, we open the file, wrap our operations inside a try block, and put f.close inside a finally block. The rule of finally is that it executes no matter what happens, even if the code crashes. This is a safe and reliable solution. But look closely at the screen, it requires 5 lines of boilerplate code just to safely write a single piece of text to a file. It is noisy and easy to forget. This brings us directly to the star of today's video, the with statement. Look at how beautifully clean this looks compared to the previous slide. We simply type with followed by our resource opening function, and then use the keyword to a variable name like as to assign it f, followed by a colon. We indent our code and write our logic. Python handles the rest automatically. Let's analyze exactly why this structure is so revolutionary for clean code standards. The magic of the with statement lies entirely in its automatic cleanup architecture. As soon as Python exits this indented code block, whether it exits normally by completing the tasks or exits abruptly because your code threw a severe error, it will automatically invoke a built-in cleanup process behind the scenes. It guarantees that the file is safely closed for you. You don't have to write f.close ever again, making your programs bulletproof. Don't just take my word for it, let's verify it with real code. Files in Python have a built-in property called .closed which returns. We write inside the true if closed, or false if open. Here, with block, and then print the status outside the indentation. Let's run the file. Look at the terminal output, it prints true. Even though we never explicitly closed it, Python automatically wrapped it up and shut the door safely. Now, how does Python perform this magic under the hood? the object created by the open function is known as a context manager. In Python, any object can act as a context manager if it follows the context manager protocol. This protocol requires two special, hidden methods inside the object's class, double underscore, underscore underscore enter underscore underscore and double underscore, underscore underscore exit underscore underscore. Let's break down the precise responsibility of these two methods right now. When Python reaches the with statement, it immediately triggers the underscore underscore enter underscore underscore a method, which sets up the target resource and passes it to your variable. Then, your indented code runs safely. Finally, as soon as the execution leaves that indentation block, Python instantly triggers the underscore underscore exit underscore underscore a method. The underscore underscore exit underscore underscore a method is where the resource closing mechanism lives, making sure everything is cleared up perfectly. Let's look at another common beginner scenario, reading a file. We change our mode flag from Ws to R, which stands for read-only. Inside the block, we can fetch all the data by calling f.read and store it in a variable, then print it out to our screen. If the target file doesn't exist, Python raises an exception, but your application state remains completely clean since no unmanaged resource handle was left dangling. Can we manage multiple resources at the exact same time? Absolutely. Python allows you to stack context managers in a single line. Look at this example. We open a source file for reading, separate it with a comma, and use a backslash to continue. Onto the next line to open our destination file for writing. Inside, we read from one and write directly to the other. Both files are safely opened and both are closed perfectly at the end. Let's discuss a common mistake beginners make. Once you leave the indented block, the file object variable f still exists, but the stream is already closed. If you try to call f.read or f.write outside the indentation, Python will throw a value error stating that operations cannot be performed on a closed file. Keep all your resource operations inside the block and only use external variables for processing raw data. While we used files as our primary example today, remember that context managers are everywhere in professional development. They are used to safely open and commit database connections, lock threads to prevent data corruption in multi-threaded applications, and open network sockets safely. Whenever you see a resource that requires setup and teardown, a context manager is always the best tool for the job. That brings us to the end of day 46. Your assignment for today is to rewrite your previous file handling exercises using this new with statement format to experience the code clarity firsthand. If you found this tutorial easy to understand, please hit the like button, subscribe to Edulexis, and leave a comment below sharing your progress. Keep practicing, stay curious, and I will see you all in tomorrow's lesson.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.